We have looked at the resting potential in a neuron that is not transmitting nerve signals. What happens when the cell is stimulated? A stimulus may change the permeability of the cell membrane to sodium or potassium ions. This alters the distribution of charge in the cell body, and if the change is great enough, it triggers a signal called an action potential that moves down the axon. How does the action potential move along the axon? Voltage-gated channels in the membrane open and close in response to voltage changes across the membrane. When no action potentials are being transmitted, most of these channels are closed. An action potential begins when voltage-gated sodium channels open and sodium ions rush into the cell. The plasma membrane becomes positive on the inside and negative on the outside. Very quickly, the sodium channels close, while voltage-gated potassium channels open, allowing potassium ions to rapidly diffuse out. The plasma membrane returns to being positive on the outside and negative on the inside, and the potassium channels close. Meanwhile, the sodium ions inside the cell have diffused to adjacent areas, causing a slight change in the polarity of the membrane ahead of the action potential. This change in polarity causes the voltage-gated sodium channels along this part of the membrane to open. Again, sodium ions rush in, and the action potential spreads to the adjacent part of the neuron. In this way, the action potential travels down the neuron like a wave. The efflux of potassium ions during the falling phase of the action potential restores the negative charge inside the neuron. Meanwhile, the sodium-potassium pump has been shuttling sodium ions out and potassium ions in, re-establishing the resting distribution of sodium and potassium ions.